My name's Ryan Maughan, and I'm a director of Transense Technologies. I'm here today with Richard Clarke, who's the engineering manager for high-performance components at the amazing McLaren Applied headquarters in Woking in Surrey. Thanks for taking the time out to join me today, Richard, to talk about Surface Acoustic Wave, or SAW, torque sensing technology. Maybe if we could start out by learning a little bit more about you and your background and how you came to be working here at McLaren Applied.
Okay, not a problem. So I've been at McLaren Applied for just over 6 years. Actually, just last week it was 6 years.
Congratulations.
Thank you very much. Actually, when I first came here, I wasn't working on motorsport projects. Oh, okay. I worked in a part of McLaren Applied called the Design Group. So we worked on very varied projects, whether that be sports engineering or medical engineering. We still did a little bit of motorsport and a little bit of automotive and some even wackier things that I probably can't even talk about.
Okay.
But it was interesting, it was varied. And I worked in there for a number of years with some great people. But then over COVID, the world changed. McLaren Applied basically doubled down on motorsport and automotive, their background, their backbone, what they know the most about. Yep. And at that point, I moved over into the high performance components team as a principal mechanical engineer, working on numerous projects or products, whether that be sensors or alternators within that team. So the high performance components team design and manufacture sensors to go into any motorsport series or vehicle you can think of.
So that's an interesting thing about McLaren Applied. Inside motorsport, it's quite a well-known business, but maybe if you could just explain more about what McLaren Applied does and the kind of products and components it makes and the kind of places that they end up, that would be fantastic.
Sure. So McLaren Applied has been around for over 30 years, as you touched on, and is well known within the motorsport world. Yep. Started as TAG Electronics, developed into McLaren Electrical Systems, and then through McLaren Applied Technologies into McLaren Applied. So there's always been that motorsport backbone. So when it first started over 30 years ago, it was about ECUs in motorsport in F1. Right. We still do that. We're still very proud of the fact that we supply the ECUs to every single F1 team on the grid.
Every single team?
Every single car.
Wow.
And from a sensors perspective, we do that with sensors as well, into F1 teams, every F1 team, but then other series as well, whether that be IndyCar or NASCAR in the States, whether it be LMDH in Europe, whether it be WEC, anything you can think of that is a motorsport series, we've probably got a sensor or an ECU or some kind of electronics running in that series.
Wow, amazing. And then more specifically with the torque sensors, what is it that McLaren Applied does with torque sensors in the motorsport industry? Sure.
So McLaren Applied first started implementing torque sensors well over a decade ago. Our first experience of that was working with McLaren Racing. Okay. When we started working with McLaren Racing on the KERS system to go into their F1 engine.
So the original hybrid technology.
The original hybrid technology. So that was working with McLaren Racing, and at the time they were running Mercedes engines.
And how was the sensor used in that hybrid system?
So between the MGUK, so the bit of the engine that stores and generates the kinetic energy.
So like the electric motor?
Yeah, it's almost like an electric motor generator. Yeah. So between that and the engine, there's a way to monitor the power going in and the power coming out of that unit.
Wow.
That technology didn't hang around in F1 for that long. Right. More people are more familiar with what is now in F1 of the MGUK, which is sort of the KERS system, and then MGU-H, which is the more regeneration of energy out of the drivetrain. Yeah. They monitor their power input and output in a very different way, not via a shaft. Yep. So that technology doesn't exist in F1 at the moment, so that opportunity went away. But we've kept up with our SAW technology. So well over a decade ago, we implemented the system in IndyCar.
IndyCar, right, okay.
So that system is implemented in IndyCar with the series, not with the teams.
And how do they use it in IndyCar? What component has the torque sensor on?
So in IndyCar, the sensor is fitted to the clutch shaft, so between the engine and the gearbox, to measure the ultimate power output from the engine. We actually sell that unit to IndyCar, the series, not the teams. Okay. So they use it for balance of performance.
Now that's a term that I've heard quite a lot, but I don't really know what it means. What is balance of performance?
So BOP, as a lot of people call it, is very simply a way for series to monitor equal performance within their series. So the data that comes out of the torque sensor in IndyCar is only available to the series, being IndyCar, and not available to the teams. So it's actually encrypted as it comes out of our interface unit. So that interface unit is designed here at McLaren Applied. The software's written here, and the hardware is manufactured here, and it's all done within Woking.
So maybe actually that's a good point to talk about what a torque sensing system actually looks like. So when you supply that to a championship, in this case with IndyCar, what does that actually look like?
Sure. So the system is fundamentally built up of three main components. The obvious one being the shaft, which is instrumented. And then we also have what we call a static coupler. So it's a ring that's normally mounted onto the gearbox housing. And that's a contactless communication with the sensors on the shaft via high frequency RF. And that data is then sent back to the interface unit. So the interface unit effectively generates the signal and bounces it off the sensors via that static coupler, and then interrogates the return signal. And then that's all calculated within the interface unit. And then the data that's fed out to the series of IndyCar is via traditional CAN bus technology.
And McLaren Applied, obviously, there's 3 or 4 different ways that you could measure torque, and you've picked SAW sensing technology for a reason. What are those reasons? What is it that makes SAW the best solution for you for this application?
So something that's great from our perspective is the robustness of the technology. So we've been running it, as I said before, for over a decade in IndyCar. We've had a few, let's call them failures. That's maybe a strong term. They were, when we've investigated them further, the failures were through abuse of the actual sensor. So let's say error or damage in handling, or they were dropped during installation. There's no vibration issues in use. There's no thermal events during use. So it's a very stable technology for us to implement. And then in terms of how that is applied into future technology, if you compare it with other techniques for measuring torque in shafts, it's very suitable in environments, not just from a temperature and a vibration perspective, but also where there's high probability of interference from other electrical devices.
So like inside an electric motor, for example.
Perfect example.
Where you've got strong magnetic fields and electromagnetic fields impacting the performance. Are there any other characteristics of SAW sensors that make them good for applications in motorsport? So
something that we found as we've particularly been running in IndyCar, but more so recently when we've been running it in different series, I'll come back to that point later, is actually the serviceability of the unit. So it turns out that when we've been talking to teams within series, so this is non-IndyCar now, they've sort of reached out to us after a couple of races and said, how do we send this back for a recalibration? And initially we were a little bit confused and said, it doesn't need it. We run them for an entire season in IndyCar until the teams or the series decide that shaft is to be retired, which is always due to the material rather than the sensing element. So there is an enforced life cycle on clutch shafts and drive shafts, etc. And actually this SAW sensing technology exceeds the life expectation of the shaft. So the shafts are replaced at that point. So from our point of view, the longevity of a particular installation, as well as the lack of the need to recalibrate the unit throughout a season.
And presumably, so you were saying the teams have asked about that surprised them because they're used to having to recalibrate?
Yeah, so I think other technologies that are in the market, which maybe we'd not fully appreciated until we started dealing with teams more directly rather than a series, they have to go back for regular calibration throughout the season, which costs money, which is air freight, which is carbon footprint, which is all these things that everybody's trying to move away from at the moment.
And inconvenience, spare shaft.
Inconvenience, all those things.
Yeah. Wow. And this is really just fit and forget, basically.
Yep, that's the feedback we are getting. The teams who have started using this outside of IndyCar are impressed by the fit and forget nature of it.
So that's a really good point to tell us more about the new kind of applications that you're finding. and where you're taking this technology now.
Sure. So I think, like I said before, McLaren Applied initially, our biggest experience with this is running it in a balanced performance environment within IndyCar.
Yeah.
More recently, we've been pushing it out, not from a balanced performance perspective, but from a performance measurement or improvement perspective with individual teams. So we've been dealing with a couple of teams in LMDH over the last year who have actually ran this unit for the season. So we've got more data now than just IndyCar. We've got LMDH data as well.
Right.
So those teams have been running them directly themselves, so not through the series or events organisers.
And from a performance improvement point of view, what can the team do with that on the vehicle when they have access to the data?
So it's live data. Live data is better than no data. Everybody wants as much data as they can when they're racing cars or bikes, for that matter. And from our perspective, there were other things that this technology presented that we not appreciated. So obviously everyone appreciates that it's a torque sensor.
Yep.
It also measures the temperature of that environment as well.
Right.
Those are the two things that we obviously sell it on. It can measure torque very well. It can measure the temperature very well. But we've had a few interesting scenarios where one customer was seeing some weird data traces when they were running it on a dyno that we'd never seen before. And upon a closer inspection, we'd realised that it was actually almost a signal indicator for the injection cycles, which confused everybody initially, if I'm being honest. But it was an interesting situation where you got to see, actually, this has got that level of accuracy and data rate that you can see things beyond what you would be expecting.
So you can actually see the firing sequence on the engine.
Yeah, in that scenario, yeah.
And that would be that would enable them to see a problem if it happened. If they had an imbalance across the engine, they'd be able to detect that.
Or if they've had a sensor fail elsewhere, it could be a nice backup. It's a nice way to correlate. It's always nice to measure everything, but if you've got two ways of measuring something, that's always better.
Dissimilar verification of that initial measurement. Yeah. From a team perspective, we see motorsport getting more and more conscious about controlling costs. The days of uncapped budgets and things are well and truly behind us. I guess having live data on the vehicle potentially helps them shorten development cycles and actually manage their costs better because they maybe need to do less testing.
Yeah, I think there's possibly an element of that, but in high-end motorsport, yes, there is a cost consideration now. Everybody's aware of the cost cap in F1, and many other series are moving towards that sort of model or are already there. From a cost perspective, from source sensors, in high-end motorsport, every single one of these shafts is going to have to go through a validation in advance. Every single one will have to go through a dyno anyway. Yeah. So it's less about reducing the amount of testing that they do. It's more about making sure that, from a cost point of view, it's reliable.
Right.
So you haven't got to replace it. Yeah. The point I made earlier about recalibration is a big bonus there, is the saving in cost, whether that be shipping, whether that being you have to have more of a physical shaft, so you've got one on the dyno while the other one's being shipped. So there are definitely cost benefits to it, but not in the actual use of it directly.
Really is about performance and enhancing the performance of the vehicle.
Very much so.
So where do you see this going in the future? You've mentioned IndyCar, you've mentioned LMDH. What other places what potential do you see to grow this in the market?
So we've got a number of open inquiries at the moment, which I probably can't dive into in too much detail for obvious reasons. Whether that be, at the moment we've focused on clutch shafts,
right?
With the IndyCar partnership, and obviously I touched earlier on the first application of KERS within the McLaren Racing car in F1. There's definitely opportunity to be looking at other areas of the vehicle where this could be installed. A big one for us at the moment is drive shafts. Right. So rather than between the engine and the gearbox, we're talking between the gearbox and the corners, so the wheels. Right. Initially, there's more of them on a vehicle, so there's obviously there's a financial benefit to that, but there's equally more data available. Yeah. You're closer to the tyre, which is the bit that it's one of the hardest bits to keep an eye on as to what's going on. So having data independently on corners is really beneficial. If you start looking at series like Formula E, where actually there isn't a clutch shaft, and actually having a drive shaft on each corner, so having 4 of them maybe, particularly as Formula E starting to look at regen and power on the front end of the vehicle, not just the rear end as well.
Yeah.
That's really interesting for us. We've also had some inquiries about less common shafts that are fitted to vehicles. So without going into too much detail, if you think about a front engine rear wheel drive car, yes, you've still got a clutch shaft between your engine and your gearbox. Yes, you've still got a drive shaft between your rear diff and your wheels, but actually you've got a prop shaft as well. So there's a little bit of interest in that.
Right.
And that's quite interesting actually, because it touches on something that is really, has good potential for SAW technology to be quite unique in that aspect. So a lot of technologies that exist rely on the material of the shaft. So they have to be steel, let's say magnetic, for example.
Yep.
Whilst we have only really raced this technology on steel shafts, there's no technical limitation on what material a SAW sensor can be fitted to.
Yeah, as long as the strain is in the right range.
As long as the strain's in the right range, and because we designed them from scratch anyway, and it's not a bolt-on solution, sort of a bit of the world's our oyster there in terms of what we can do from a design point of view. When you start looking at components like prop shafts, they're not necessarily made out of steel. They could be made out of hollow carbon fiber, for example, in certain series. So actually, we've got some really interesting projects going on where we're looking at this technology in a way that we've not looked at it before, but in a way that torque sensing's not been looked at before.
Yeah.
So there's some really interesting applications that we're looking to branch out into.
It is a thing, Surface Acoustic Wave opens up potential to measure parts that you couldn't measure with any other technology. It expands that market greatly.
Agreed.
You mentioned two wheels. How would you use this on a motorcycle?
Honest answer, we're not quite sure yet. Delving into that a little bit more, two-wheel vehicles are always a challenge from a packaging perspective.
Right.
Because this isn't a bolt-on solution, we have an opportunity to make it a bit more efficient.
Right.
Compared to maybe other technologies or other techniques of measuring torque. So we are exploring what that could look like on a motorbike. Right. There are some very different challenges to packaging it for a two-wheeled vehicle rather than a four-wheeled vehicle.
You need to get it into a very small space. Yeah.
Yep.
Okay. And that presumably is a strength of the technology compared to other methods of measuring torque. You can package it into a space that you couldn't fit a normal or more conventional torque sensor, let's say.
Yep, that's definitely a strength, and I think that fundamentally comes from the fact that it's not bolt-on. We work in partnership or collaboration with the teams or with the manufacturer of the shaft to say, here is the shaft without a torque sensor. These are the features that we need adding to it at manufacturing stage. So it's not a sensor that we just screw onto an existing shaft. It has to be manufactured from blank sheet of paper.
Right. So looking forwards, what do you think the market looks like? Where is McLaren Applied planning to take this in the future? Do you see this as being a large market potential in motorsport?
So talking from a high performance components arena within McLaren Applied, this is a big part of our strategy. So we are pushing it hard into different series, into different teams. We've got other opportunities looking at balanced performance.
Right.
We are currently in the final stages of working with IndyCar on their next generation of powertrains. So we've got some good longevity in IndyCar. Yeah. They're really happy with us, so that's great. We have some of the LMDH stuff we've touched on recently.
Yeah.
We've had more inquiries from that series. We've had a few inquiries outside of motorsport, which isn't our bread and butter, but stuff that we're willing to have a conversation about and see if it's something interesting. But from a motorsport perspective, I would like to think that with the kind of level of inquiries we've got at the moment, we're struggling to keep up with them at the moment, which is a great sign.
Yeah, good problem to have.
Where I touched earlier, where particularly from a high performance components perspective, we have sensors in pretty much any motorsport series you can think of. I can't see why SAW sensing couldn't move in that direction. Right. So any series you can think of, let's see what we can get in there. And we are talking to such a large number of them at the moment that I can see that being a substantial proportion of our portfolio within high performance components over the next 5-10 years.
Brilliant. Well, we're very much looking forward to working with you on that. It's been a fantastic business relationship between Transense and McLaren Applied so far. And I think from what you've said, we're looking forward to a really positive future. Thanks for taking the time to talk to me today. It's been really interesting to learn a little bit more about what you're doing here.
No worries. Thank you for coming down.